think we can start. So my name is Michael Staib. I'm the author of the Hot Chocolate GraphQL library in .NET, so one of the biggest GraphQL implementations in the .NET ecosystem. And I'm also one of the members of the GraphQL Technical Steering Committee. Today I want to talk to you about GraphQL observability. And actually, observability stands at the end of this talk. It will be essentially the result of our analysis of the problem that we can face in distributed GraphQL systems. The issues we will explore actually are not just a problem that we will face with GraphQL. It could also happen in REST deployments or gRPC or whatever. But in GraphQL, we have some unique challenges, because in REST or gRPC, you actually can very easily test what the performance characteristics of certain requests are. With GraphQL, that is more difficult. Let's have a look at a simple GraphQL query. This, you could say, is the hello world of GraphQL. It's a very simple query that just asks for the currently signed in user of our system and from that user for the name. It's actually the slide I open with when I explain what GraphQL is. And if we send such a request to our GraphQL backend as we expect, we get something very close to our request, almost like our empty JSON graph was filled up with data. We get the data that our GraphQL server resolved. But that's just a simple GraphQL request. It's easy to look at what the performance characteristics of such a request would be. But GraphQL is not that simple, because we can drill in. We can ask for more data as our use cases change or our clients. Maybe we are going from a mobile to a desktop client, and now we want to display more data. And it's not only about like simple sparse fields, like here we are actually getting just more data from our user, but we can really drill into connections in GraphQL, like maybe get the friends of this user. And we could even go deeper, get the friends of the friends, and so on. What that means is that it's not clear in the beginning what services and what components we will use in GraphQL. So typically in GraphQL, or that's how Facebook started, we have a system where GraphQL is a very thin layer of our business layer and allows us to select the data from our business APIs that we need for certain components or use cases or whatever. But as GraphQL was open sourced and introduced to the community, we saw more of the cases where we distribute or we essentially compensate microservices. You could say the GraphQL monolith on top of our microservice architecture is often a compensation for the complexity that you would have in knowing where's this endpoint, where do I get this data. And now with GraphQL, you have this single point of entry. But it also makes our task in predicting how performant each request is, or how performant our system is, more difficult. Because if somebody changes something in one of our downstream services, then our performance characteristics might change for the whole system. Yeah, typically, that is one of the setups that we see often in the wild, where we have a couple of topic domain services, I would say to them, not even microservices, that care about certain topics. But as GraphQL matures and also takes on these federation concepts, what we see more and more is these federated concepts where you have like even multiple GraphQL servers and have multiple components underneath and are aggregated with the GraphQL gateway. A common example is, for instance, Apollo Federation. So how do we analyze issues in such an environment? And often issues, when do we discover issues? Most of the times when someone comes to us and tells us there's something wrong with your system, maybe an admin comes over to the developer teams and says, look, our system is at its limit, something is wrong, you deployed something yesterday, at best, maybe on a Friday, and then you run into issues over the weekend. So typically what we see in projects, let me get out of this here, is something, and let me just start a demo. First, let's start the client. And this is a React client, and we have a backend for cryptocurrencies. Not that I'm really invested in them, but just because it's fancy. And let's .NET watch that. And use some Chrome here. Okay. And it's on 3. Okay. So let's say we run into problems at production with our application here. How would we analyze that? Typically what developers do, at least in a naive way, is maybe run it on our local system. Have a look at what the system does when I do refreshes, maybe when I go into maybe the Bitcoin data, have a look at if that is slow, maybe not, maybe yes. As I go through this application, I actually have to say it's kind of smooth. It really runs very well, and I don't see any performance issues in this system. And that's typically because on the local machine, your stuff will almost always run very well. And a naive approach here could be that we maybe look at some logging data. Logging data might be on our console, not the best idea, but that's maybe a first indicator to look at issues that we would face in our application. So if we, for instance, let's go back to our initial list, refresh that, and let me just pull that in. Refresh our application, and we can see it's really, really actually nice and quick. But what we can see is that there's a whole lot going on here. We can see that there are SQLs going on, there are more SQLs going on, and there are even HTTP requests going on. So there's a whole lot of data being fetched just to get a list of simple cryptocurrencies here. And if I even just drill into one of those cryptocurrencies, I can see there's a whole lot of HTTP requests actually going on. You can see here is something being fetched from a price API. As I said, with GraphQL, we often have these aggregation of REST services or gRPC services. So there's maybe something else going on behind these services. But that also shows the limitation of logging, actually. You can see what's happening in your system, but it's kind of siloed off. And also these data is not really accessible for me. Like, it's not connected. And I can sift through these log files. And that's what we did for the last 10 years, maybe. But it's very hard to analyze them. There are tools for that. And most people will not look at their console. But still, it's very disconnected. And I don't see what's going on here. So the first approach to solve that in GraphQL was to introduce something that we called Apollo tracing. It's a protocol to look at the graph data, essentially to look at the resolver performance. So how would we do that? Let me go out here and let's have a look at some code. So this is my GraphQL server. So quite nice and organized. And what I want to do is add some more insights into my graph. And in order to set up Apollo tracing, and we will look at what Apollo tracing really is, I can just chain into my GraphQL configuration, add Apollo tracing here. And in our case, we do always. This is actually not a good idea because Apollo tracing will create a huge amount of data and put that on our request. And we actually don't want that. But let's do it, just to get some idea around that. I have to say that Apollo tracing is actually now deprecated, but it's a first step to have a look at this. And it's deprecated for the reason I already said. It produces a lot of data which it puts in our payload. So what is Apollo tracing? I'm using here now, let me just get into that. We are running on port 5000 and it's GraphQL. Let's open that. So this is Playground, another GraphQL IDE. And what we can see here is essentially our schema being fetched, I hope, or not. Oh, yeah, that was a mistake made. I should run my server. Okay. Okay, my server's running. Why is it? Ah, there. Okay, recovered. Okay, so with this IDE, I essentially can run GraphQL queries. So I can go in here, say, okay, I want to fetch the assets. And maybe from the assets, I want to grab the nodes, which are the actual assets. And from there, maybe the name. And I can run that. And then down here, I have this tracing blade, which essentially tells me how long this resolver ran. Like in this instance, it just took 60 milliseconds, so that's negligible. In order to get the actual performance inside, we should grab maybe some proper request from our client. Let's have a look at that. So we go into our developer tools here, and maybe just rerun our GraphQL client fetch, and then we can see here's our GraphQL request being made. And we can just copy that over into our GraphQL IDE here. And you can see it gets a variable in here, and that can be defined down here, and we can also grab that from our request here. Let me do that. And then let's see. And then we can rerun this thing, and we get some more performance insight. Like we can see, there is a price change, which actually takes 49 milliseconds. So this is the longest time we are waiting in this request. So we get kind of an idea where we spend some time on processing. But you also can see why Apollo tracing is actually deprecated. First, it produces a whole lot of data on your payload, on your request payload. And second, it doesn't really connect this data, like the runtime data, to what's actually happening in your system. And that is kind of bad. The second thing here is, what we've looked so far at is actually logging and some kind of tracing here, but not in the way that we are being informed that something is wrong. We actually have to actively look at things, explore what is wrong. We have to search for things. And that kind of is a bad thing, because we only will react to problems. And that is where actually observability comes in. So observability is kind of bringing also a lot of these data together. But instead of constantly polling systems, looking at systems, trying to reproduce things, we're actively informed. Data is always collected by our system. And we kind of can create trigger or set, like use ML to get informed when something behaves different or if our system gets into trouble. And then we can react to this data before our business is disrupted or before our client calls us telling us that he cannot look into his bank account or whatever. So observability in the past was very difficult. And I worked on a large project, I think 4 years ago. And we built our own observability solution. We essentially injected into each request, HTTP request, we injected a correlation ID, we created something, we used event tracing for Windows back then to create spans, and we had to aggregate, we had to write things to collect the data, to push it to an endpoint. We actually looked back then at solutions to handle this large data stream and make it really accessible. But it took a huge amount of time to build up that system. And there was one developer just working on this solution back then, and it was never good. And that is where the industry came together and created OpenTelemetry. And that is a standardization to implement observability solutions. And actually, there was a lot of work around that. There was something called open tracing and open sensors, which were competing projects. And luckily, Google, Microsoft, and everybody came together and said, let's put these two projects together and make one approach to introduce OpenTelemetry. So when we talk about OpenTelemetry and observability in general, there are a couple of terms that are important. So first, we want to instrument our API. And that means we want to hook into events and so on into our system and produce data. And that data we want to collect and export. And these are important terms. We will pick them up over the course of this talk and talk again about them. Another important thing that we talk about when we talk about OpenTelemetry is the term melt. And that means metrics, events, logs, and traces. So logs is what you know today. It was we use today. It's what we print often on the console, what we put in files, what we had over the years. Then we have traces, and traces mark, and we use in .NET the API term spans, where we essentially put spans around important things like an HTTP call, a database call, or things like that. And logs that happen in this spans are correlated. And events is essentially things that happen on our system. If you think about the vending machine, if you press a button, that's something is happening there. So these are our events that we collect. And metrics are like the CPU cycles you're using, the garbage collection runs you have, the requests that go through your system, and so on and so forth. So when we look at an OpenTelemetry instrumented application, we essentially have a platform API. And in a Microsoft solution or in a .NET solution, we have this new activity API, which allows us to create these traces. We have our logger, and we have our new meter API to produce metrics. And then we have the native OpenTelemetry SDK. It's open source, it's on GitHub, And Microsoft is contributing to it. So it's Microsoft engineers that are contributing to that project. And the OpenTelemetry API essentially takes this data that is being produced through these generic APIs that we have in .NET, process it, and then export it. And exporting means that you're essentially transforming the data and giving them to a certain OpenTelemetry solution, like Jaeger or Elastic or whatever you like. Or Honeycomb is also a good solution. In a typical setup, we would not just export to our OpenTelemetry backend, but we would have something like a collector. A collector lets us essentially offload the telemetry data to another service that pre-processes the data and then batches it to the actual telemetry backend. So while I, in the demos, now will not use a collector because it's more setup. In general, I would do that because, like, if you have a Kubernetes cluster, for instance, with multiple pods running there, and each pod would directly go to the telemetry backend and push the data there, you generate a lot of overhead and use a lot of network connections. And using the collector essentially allows you to centralize that and also to avoid like side effects of this telemetry data generation. So this lets you more control how your system performs. In our demos, we will use Elastic Observability today, and I hope the internet works because I have everything in the cloud. Okay, let's have a look at how we can get that together. Okay, what we have seen so far is that we don't really see the performance problems in our system. So how could we instrument it to make everything visible here and let people explore what actually is happening with our system? So the first thing is we need to put OpenTelemetry in here. And I already did that, kind of. So I added all the packages. And at the moment, OpenTelemetry is not released yet. So we have this version 1.2, release candidate 4, and 1.0, release candidate 9. And that has something to do with the core libraries have a certain preview version. And also the exporters and instrumentation APIs have certain versions. And not every release candidate aligns with the other. So at the moment, it's a bit still early days, but it's already really, really good. If you don't want to head into like the OpenTelemetry API yet, then there is also the solution to use vendor-specific APIs. Like Elastic has a lot of packages that actually allow you the same thing, but are already production version. I recommend if you have a new project, go for the OpenTelemetry APIs. They are already release candidate phase. Still, there's a lot happening, but they already work very well if you know the right versions. Okay, so what we are using here is first the ASP.NET Core instrumentation and the HTTP instrumentation. That means we will automatically get insights into HTTP cores done through the HTTP client and also everything that happens in our ASP.NET Core system. Also, we are using the OpenTelemetry protocol exporter. That means it's also called the OTLP or OTPL protocol. And the Elastic backend that we are using is actually supporting this, this protocol. If you're using Jaeger, they have a specific protocol to export to that system. Okay. Another important thing that we are using is the Hot Chocolate Diagnostics package here. That already exists in a release version, so we're just using a preview because it's more fun. Okay. So how do we instrument an API? So the first thing is that we need to expose some metadata about our service. That means we put an API description in here. And for that, we use the resource builder. And what we expose essentially is that our API is called Coin API. It's in the demo namespace. That's just if you have a lot of applications, you can better filter through them. And then we say, okay, this is actually version 2. And we have the development environment, and we are using .NET 6. Okay, so we are exposing already some information about our system here. Then we talked about metrics and traces and so on. And we have to register what we want to expose here. So we can say, let's expose some metrics, some OpenTelemetry metrics. And we want to expose here the HTTP client instrumentation events and also the ASP.NET Core instrumentation events. And we are exposing that for our API. That's the description we made further up in the file. And as I said, we are going to our OpenTelemetry backend from Elastic and pushing our data there. So it's actually really easy to set that up, right? You point to your Elastic server there, then you put some API key in there, and then you're done. And if you are using like the collector, you just point to a local collector, and actually all the connection details are in that collector. That's also a reason why I would use the collector, because you don't have to copy the API key into every service that you're hosting. Okay, the second thing that we need to put in is our traces. And again, we are collecting here the HTTP client information, the ASP.NET Core information, and we are also collecting the hot chocolate events, so our GraphQL events here. But there is one more thing we have to do before we can use that, and that is actually instrumenting our schema. Because producing tracing data also has a performance impact on your system. It's not for free, right? So it's not a lot, but you have to be aware about that, and that's why by default we don't instrument the API. So in order to instrument that, you just say add instrumentation here, and you're done. And now we can just run our system. It's not ideal, we will see why, but let's go into that. So I'm going into my Elastic backend. Yeah, it's coming up. No, not coming up. Okay. Let me log in. Okay, so I can see here's my NDC demo. I can go in here. And then I see all the Elastic products I can use. Actually, when I tell people we are doing observability with Elastic, many people don't realize that Elastic has this great solution for observability. All the people are associating Elastic with Elasticsearch. What they did is essentially build on top of Elasticsearch all this observability, because with Elasticsearch you have these great aggregations and stuff. You can create these Kibana dashboards and so on. And what they essentially did is taking all this great technology and building a very nice observability solution. So what we can see here first is this APM. And there we have, that's the first area where we focus on. And there we have something called a service map. And before we even look into our system, we will have a look at this service map. But at the moment, you can see in the last 15 minutes, there was no data being produced. So our system is already up and running. And let's go back to our client here. And let's maybe go to the root. and we run it a couple of times to produce some data for our telemetry backend. Go back here, let's refresh and see. Wow. We can see that there is suddenly some data. So we can see there's a coin API, and that uses actually an Azure function in our system. Let's do a bit more. Let's go to our Bitcoin here. I'm just refreshing that a couple of times to get more data. And let's refresh that again. Doesn't produce a lot more. Let me just refresh that in. Oh, an anomaly is detected. Okay, we can look at that later. Okay, it should show more. But let's dig in further. And I think the problem that we are having here is actually a different. Yeah. So what we can see here in our transactions is actually that we have this GraphQL endpoint. And we're getting a lot of requests into that. You can see that's my HTTP that is coming in. And then you can see here's my GraphQL request, which is called view container query. And then you can see a lot of other things. And this is the latency distribution over our request. And we could zoom into various things, and then you can see, okay, we just have GraphQL here. And that is because we have this HTTP standard span from ASP.NET Core, and it thinks all the requests going to that endpoint are actually the same. And that's a difference with GraphQL. We actually have to rewrite some spans here to make it more discover and tell the system that these are different requests that are going to this endpoint. So the good thing is in OpenTelemetry that we can standardize anything, even the events or the spans from somebody else. And in this case, we want to rewrite the spans from ASP.NET Core. So how would we do that? It's quite easy. We can pass into this instrumentation instrumentation configuration here some configuration and tell it to rename our root activity. That's the first thing. And also, and I know that, is we might want to include the document. The document is the actual GraphQL request. That's a bit more data, but it's useful to analyze what GraphQL request actually causes the issue on our system. And to make it very neat, let's create something that we call an activity rewriter, an activity enricher, actually. .cs, and then we call it a custom activity enricher. So an activity enricher, and that is specific, like this is how we do it in Hot Chocolate. In ASP.NET Core, they essentially have a Lambda where you can do the same. So every implementation does it a bit different. Let's generate the constructor here. That is just passed in by the system, so we actually can create these events in a performant way, so we get a string builder pool here and stuff like that. We don't care about that. But then we can override a couple of our events. You can see, so I can enrich the batch request, for instance, or whatever I want. In our case, we want to rewrite the root activity of ASP.NET Core. So we actually will return here the display name of our root activity and rewrite the root activity of ASP.NET Core so we have more useful data. Okay, let's hook that quickly up and then we run our requests and then we will get more useful data. Okay, let's go here. Builder .add singleton and then activity enricher Okay, let's rerun this thing. It will work. Then just refresh our request here a couple of times, and then go back to Elastic. Then we actually will see some useful data. Okay. So we can go in our Coin API. Let's refresh that. Sometimes it takes. Let's rerun it again. Bear with me. If not, then I have also, yeah, there it's come. So now we can see, like here we have, that is how our new requests now look like. There we can see we have the viewer container query. That's actually the query name that the client guys gave to our GraphQL request. And we can see that we do an asset by symbol here, which is just the root field. We don't see the full GraphQL request here, but that's okay. It's just as a header. And now each request will be tracked distinctly in our Elastic cluster. And we can now see much better what's going on in our system. Like we have the latency distribution, and this is essentially, you have buckets, how well your request performs over time. And like here we can see 2 of our transactions are 78 milliseconds. And we have like this one here, which is 1 second, probably when the server was not warm, and so on and so forth. And if we go into this span, and these are the spans I was talking about, we can look at metadata. For instance, we can see the GraphQL request that we are looking at. We can also look at the hashes from our request, or what request type it is, and so on. But we also can drill in. Like we can see this span here, for instance. You can see this path. This is one specific field in our GraphQL request, which took 44 milliseconds. And we can see that there's a batch happening here, and that there is a HTTP request going on. And we also can have a look into that. It's actually calling our Azure functions that we saw in the service map initially. And we should actually get some insights of our map. But don't fear, because I actually have prepared some more data before my talk. Let's take 120 million. Let's look at the longer span. Price API. So what we should see. Let's have a look at if we can get this request out. Production. I'm very sorry. This worked so well in the last presentation. Okay, what we should see is that we actually can drill into our other service here. And let me just pick that up from my price API. We should be able to look into our price API here, and then actually see even through to our database. So here you can see that is actually the Azure function that is behind it, and there we can see our database calls being made. I don't know why it doesn't correlate this yet, but hopefully my production system is up and we can have a look at that. Okay. Never happened. And then I can make my point, maybe still. Workshop queries. Okay, that should work. Okay, this is actually the same service, but I put into production. So let's quickly copy over our request here and put that together and produce some data on our production system. And then hope. Oh, I know. So before the talk, just 5 minutes before, I thought I had this API key in my system from the last presentation, and I wanted to get rid of it because I thought it was visible on my thing. And the Azure function actually has this old API key, so it's not reporting anymore the performance data. Let's see if we can fix that. That was... that's demo gone wrong. Okay. Okay, and here that's actually our Azure function, and I made some big mistakes in here, and we should have seen them by now. But actually, I killed this API key here. Damn it. Let's just quickly copy that over and redeploy it, and hopefully it will not take for the whole talk to appear on Azure. Let's grab this one. Put it in our Azure function, put it in the other Azure function. Do we have more Azure functions? Everything is all right. Azure here. Functions, deploy, MVP credits, then there. Let's see if that works out. Deploy. This is real life deployment. Okay, going to Azure. This is an example why you shouldn't change your demos just 5 minutes before you do the talk. Okay, let's see if we get better data now. Let's use our application maybe also a couple of times. Yeah, maybe looks good that the network layer is not anymore there. Let's see. Yeah, it's coming back. Okay. Okay, let's have a look. So we go on development. Refresh. Last 15 minutes. Could be that's too late. Yeah, it's dead. Oh no, it's coming. That's now my so this is what I showed you initially and didn't work, and it was because of this API key. Now we also get the data. So that's actually what I wanted to start with, but I didn't get that my demo update that I produced actually wrecked the whole demo here. So what we can see here is without specifying that, the system can, from our tracing data, actually create this nice service map. So we get the coin API is actually using Azure functions downstream, and then it's using a Postgres database here. And if we go into our tracing data now, hopefully, yeah, now the data is all there. We can look into our coin API in development. Then we can look at our requests that we are producing here. And if we get the right span, maybe, we should see this picture. And so that is not anymore just an HTTP request here. We actually can see that is my Azure functions that we are calling. We are calling version 2 of my Azure functions. And what we can see is that it actually has 2 database requests. And we have another Azure functions here that is having 2 more database requests. This could be the moment where we think that that could be something suspicious. So let's maybe go back to our client and let's have a look at what's actually happening when we call our list request here. And, okay, that should be enough data. Let's go back to our coin API. Refresh that. Maybe it's coming in because it's now. Okay. Come on. We should have been here a couple of hours ago. Okay, so now it should be there. Let's go in the coin API. Okay, now we can see the dashboard request is coming in. And when we look at that, we actually can see that there's a couple more spends happening here. There's a batching happening here. So we're batching from the GraphQL to our Azure function. And we can see that there is like a lot of database calls happening, like 1, 2, 3, 4. And we actually can have a look at these database calls and have a look at them. And we can see that although we are batching to our Azure function, it loads the price information for cryptocurrencies one by one. You can see the limit here. You can see that it's actually selecting on top of the ID and just taking one ID by the other. So this is the moment where you actually get visible, or you make visible that in distributed systems, you suddenly can look into the other system. You don't just get the picture of the GraphQL server itself, but you also get the insights into the Azure functions and also into the database. And like this is Postgres. This is also working for MongoDB, for other systems. So all the vendors are actually providing new OpenTelemetry integrations. So you get that for free. You just plug that in, like I did in our solution here, and then you get the data for free. But you can extend that also. Like I showed you, we wrote the root span. We can also provide our own metrics to that. And that is also something we haven't yet looked in, and I don't think we will get to that point because I messed up the initial demos. Because the cool thing with Elastic is actually that you can define now these alerts and rules. Like I could say now to my system, that's actually very late that I discovered that. I had to look at the spans. In a real system, we would create alerts and rules, maybe for latency, that we say, okay, if the latency for a request is out of bounds of a request, or if there are anomalies, like we suddenly detect that there are lots of database calls in our requests that weren't there before, then send me a mail. Or do something else. You can add tasks to that and do something that will make sure that your engineers are aware of this changed behavior before your customer really calls. Okay, so there's one more thing. Let's try to get it in. And that is actually metrics. And we haven't looked at them. At the moment, we just looked at metrics, traces. And metrics allow you to have much simpler indicators. Don't look at the spans. We actually look at very simple numbers, like requests per second that we get through our system. So how would we use that in our GraphQL API? So we already set up metrics here, and these will provide like general metrics, how many HTTP requests go through, maybe GC insights, and so on and so forth. But how do we hook up custom events into our system? And that we would do by creating something that we call in GraphQL a Diagnostic Events Listener. Let's see, yes. And let's just create this guy here, log interceptor, and it's an execution diagnostic event listener. And we then can essentially override any event that is happening in our execution engine. And let's just use execute request here. And maybe I already have a template for that. Yeah, let's take that meter. So then we put a meter in, and that's a new API from Microsoft. I think they introduced it in .NET 6, which allows us to produce metrics, not OpenTelemetry specific, but we can hook that up to OpenTelemetry to report these metrics to our Elastic backend. So I'm calling here my meter demo.graphql, it's version 1, and my counter that I'm setting up here is requests. And every time then there is a GraphQL request happening on our system, I will just count it up by 1. There could be other things, like you could have meters that measure how much cryptocurrencies are bought every day or whatever. You can put these meters into critical parts of your system and measure how well it performs. So we are just putting it here so to measure the requests that we have. And then we go to our OpenTelemetry metrics section and say add a meter. And we call the meter, let me just copy that thing here. That is our meter that we want to report to OpenTelemetry. And then we essentially are done. The one more thing that we have to do is register our new diagnostic events here. Diagnostic event listener, how did we call it? It was the metrics. We hook it up here. Just run it. And then we should be able to just rerun our client again. And our meter should be tracked. We should be able to query it from Elastic. And why it always takes a bit is because by default we are batching these requests. So essentially the OpenTelemetry API will wait and not send every request to Elastic, but only after a certain amount of time, or there are a certain amount of requests there. So we now have here our inventory section. We can just auto-refresh that. And we should have now here our request. So that's our request. That's our new metric that we have here. And yeah, we have it here. I can just refresh it. And there should at some point be some insights into it. Let's go for an average. Okay. Requests. It doesn't matter really. Let's go for 12 hours. Update. Yeah, there you can see that's what I did before when I created this little demo. You can see here I had 22 requests on average on my system in a certain amount of time. And you can then go and add these rules on top of that to get informed when these go out of bounds. Like we could say here that is a max requests alert, and then we can essentially say when average of requests is above 1,000, we should tell an engineer. That's how easy it is you can create these notifications in Elastic. And from my experience, we are using Elastic in production now in many systems. And even though we didn't know we had production issues, we suddenly could see them. Like we went into this that we just explored our stuff that we hooked up there. We looked at our request, and then we suddenly, let me go back here to the Coin API. Then we discovered exactly what we see here, that we had multiple database requests we weren't aware of, and that things weren't batched correctly, and so on and so forth. So just by hooking that up into your system, you will already discover things that don't run well, even if you didn't discover them so far. And I'm really sorry that things fell apart today, but we are at an end. I'm next week in London again. Then I speak about building modern GraphQL applications at the Microsoft Reactor. That is more an introduction to GraphQL with hands-on. So if you like to learn more about GraphQL, then you're welcome to join. Our project is open source. You can find us on Chili Cream Hot Chocolate on GitHub. And if you want to follow me, you can. If you have questions, shoot.